All right, this is actually a re-recording of this part because I did it before and I obviously did not have enough coffee. How do you find the equilibrium value when the I minus A is no longer invertible? This is the crib sheet that I gave everybody, and I did this in class with group A fumbling about, but I did it better with group B. I kind of forgot why I had that crib sheet in there and what I'm supposed to do. But I'm going to walk you through it now. What we need to do is we need to go back to this model that we have and then take in the equations. Let's put them in snipping tools so that we can actually pull it into the Mathematica file. Here we go. And you had this crib sheet called How to Find the Equilibrium Vector. It says no free variable example, but I am going to get a free variable this time. So I'm going to make that really small. Now the way this crib sheet works is I have the directions written in text here. So those are just the instructions. Whenever you go behind an actual equation or anything you have to do, you just hit Shift Enter. So I'm going to enter the A first. That says step 1, enter A. So let's do that. 0.85, 0.50, 0.15, and 0.50. And then hit Shift Enter. And then I'm going to enter my D, which in this case was 0, 0. Oh, I didn't want to do that. I actually don't need the D because I'm going to remember it anyways, but let's put it in anyways. I'll show you where you need it. It's 2 rows, 1 column, so it's going to be, in this case, 0, 0. And then no nakedness, make sure you cover up your D. And then I do this identity matrix 2. I want to show you what that is. I did this before, but I just want to show you. If I put identity matrix 2, what I get is the 2 by 2 identity matrix. And what's nice about the identity matrix is it behaves like the number 1. Mathematicians get really jazzed about something like that. It is really, really cool. So this behaves like 1. If I had 3 equations, I would work with identity matrix 3. We did that in class. And then you see it's exactly the same looking matrix with 1s down the diagonal and 0s everywhere else. And if I multiply the identity matrix with anything, so if I do identity matrix 2 times anything dot this with A, I'm just going to get back A. So if you look at that, that's A up here. It's exactly the same thing. So that's what the identity matrix does. I need it here, so I use it. I'm just going to erase this because I'm not using this. This was just to show you what it was. But right now, what I need it for is this bit right down at the bottom. I have the instructions here. So there's a few questions in class of why we're doing this. It has to do with, if you look at identity matrix 2 minus A, this is almost the same thing we had when we had a one-dimensional DDS. We had 1 minus A when A was just a one letter, wasn't a box of numbers. So the identity matrix acts like the number 1, and the box of numbers A acts like the little a that we had in the first block. So I need to calculate this, Shift Enter, and I'm going to place that as a matrix so I can see it. I couldn't figure out in class how to do this easily. But what you need is you need an augmented matrix in here. Since I'm working with 2 by 2s, my augmented matrix is going to be a 2 row, 3 column, because I'm going to row reduce something. And what goes in the first 2 blocks? I couldn't figure out how to copy and paste, but I'm going to copy and paste this matrix form guy here. And then I'm going to put it in the 2 by 2 portion here. So I'm going to hit Control V, and it pasted that matrix form here. And don't worry about the apostrophes. It just is something that happens when I copy. Then I'm going to put my D vector here. Now I can go up and copy that. That's kind of why I asked you to do that. So in case you forget it later, you just copy it, and you could paste it by just highlighting this and paste it right into there. Or you can type it manually in. Then hit Shift Enter, and it's going to row reduce this augmented matrix of I minus A with the line with D next to it. You're really solving for the solution to I minus A times a missing variable is equal to the 0 vector. And this is all in your book, by the way. It's not, I'm leaving out a lot. I'm trying to figure out how to say it to you without confusing you. But what I get here is I get a system of equations. It has wiped out the second row. And this is why you have to use this this worksheet. And you can't do it in the simpler way. Otherwise, you're learning two things. I'm just trying to teach it to you with one thing. The next thing is to extract out the equations. And so I'm going to take this thing here. Let me snip it out and extract out the equations. So if I extract out the equations, I've done it here already. I get, some of it I've done, so you can see it, but really what I get is just going back to the previous things we did with linear systems. I get x1 minus 3.3333x2 is equal to 0. That's the extraction of the equations. And what that means is if you solve for x1, it's equal to 3.333x2. Or that's what I've written here. Now, if I'm keeping everything in the repair shop, or it's a working server, then I'm never going to get anything other than 110. 110 was my initial condition. If you go back here and look, 110 working servers. Some of them are now in the repair shop, and some of them are working servers. But since I'm not throwing anything away, we're always going to get 110. And I did this in class with you guys as an in-class assignment. Because the sum of those, even at equilibrium, is going to be 110, I can use these two equations and solve specifically for the x1 and x2. The x1, if I substitute in 3.33x2, I can now solve for x2, and lo and behold, I get x2 is equal to 25.4. And so that goes in this second slot because x2 is the second component of the equilibrium. Remember, I was solving for the equilibrium. I got an infinite solution of equilibria. But in this case, I really only have one solution because the equilibrium has the property that the components must add up to 110. And when I first shot this video, I didn't do that. I just wrote down one solution out of the infinite, some random one solution. I really needed this sum to be 110, and it gives me one solution. How do I get the x1? Well, I take whatever I have here. I have x1 is equal to 3.33 times x2. I substitute the 25.4, and then I get exactly 84.6, and I put it into the, it says do not round, but I definitely rounded, so I'm not quite sure. Rounded to the nearest tenth, and it seems like that's what you put in.